Welcome to Lesson 3.6, Equivalent Fractions. Today we're going to talk about using division to find equivalent fractions, using multiplication to do the same thing, and using division and the GCF to find fractions in simplest form, and to use the LCM to find the least common denominator. Alright, so first we need to know what all these words mean. So equivalent fractions are fractions that have the same value but are written using different numbers. So let's look at half. We know that 1/2 is the same thing as saying 2/4. These are what we call equivalent fractions. Okay, they are worth the same, but they have different numbers representing them. So let's look at it this way. So here's 1/2. And here's 2/4. It's still covering the same amount. They are equivalent fractions just using different numbers. Or think about money. So if you have 2 nickels, it's the same thing as having 1 dime. They're equivalent, but they're represented by different numbers or by different coins. Okay, kind of the same idea with equivalent fractions. The least common denominator is the smallest multiple that the bottom numbers in a fraction have that is the same. So in short and sweet, the least common multiple of the denominators. So in this case, let's look at 1/3 and 1/4. Actually, let's go 1/3 and 1/6. The least common denominator of 1/3 and 1/6 would be 6, because both 3 and 6, so 3, 6, okay, both 3 and 6 multiply to 6. So it's the LCM of the bottom 2 numbers. Simplest form. Simplest form is when the numerator and denominator have only 1 as a common factor. So if I have 9/12, in simplest form, both of these can be divided by 3. So in simplest form, 9/12 is equal to 3/4. This is simplest form. So 3 and 4 can only be divided by 1. Okay, and then like and unlike fractions. Like fractions are fractions that have the same denominator. Okay, so they can be improper or proper. So 1/3 and 4/3 and 2/3, all like fractions. Unlike fractions are fractions that have different denominators. So in this case, unlike fractions would be like 1/4 and 2/5. Their denominators are different, so they are unlike fractions. All right, so talking about equivalent fractions, how did we go from 1/2 to 2/4? Well, if we look at the math behind it, we have to look at and use the golden rule of math. We know that what you do to one side, you do to the other. Or what you do to the top, you do to the bottom. So how did I go from 1 to 2? Well, I know that I multiplied that by 2. How did I go from 2 to 4? Well, I multiplied that by 2. So I took 1/2 and I multiplied it by 2/2. Now we have to be careful because 2/2 we know is equal to 1, because any fraction that has the same number on top and on bottom is equal to one whole group. Well, what number can we multiply any number by and still get that same number? We know from the identity property that that answer is 1. So with equivalent fractions, you can multiply by a fraction that's equal to 1, and you get a number, or you get an answer that it's still equal. Okay, so with multiplication, if we do 9 times 1, we get 9. But with multiplication of fractions, if we're looking for equivalent fractions, we get 1/2 times 2/2, which we know is equal to 1, and that gives us 2/4. Well, 9 is equal to 9, and we know that 1/2 is equal to 2/4. So it's the same idea. You're multiplying by a different form of 1 to get an answer that is equal but using different numbers. Okay, so remember, whatever number you multiply by, it has to equal 1. If it doesn't equal 1, then you didn't use correct numbers. So if you have 2 and 3, then it's not equivalent anymore. All right, so most importantly, you have to remember whatever you do to the numerator, you must do to the denominator and vice versa. And when you multiply a fraction to make an equivalent fraction, you have to remember that doesn't make the fraction bigger. They're equal, it just makes the numbers bigger. Okay, so it's not that 2/8 is bigger than 1/4, it's just that 2 is bigger than 1 and 4 or 8 is bigger than 4. So let's look at what's happening here. So I have 1/4 times something equals 2/8. Well, I know that that something has to be 2 over 2 because 1 times 2 is 2 and 4 times 2 is 8. So I'm multiplying by the same thing on top and on bottom. So let's take a circle, and I will use my drawing tool here. So we have a circle and we split it into fourths. Well, when I split it into fourths and I have 1/4 shaded in, I'll shade it in with blue, so 1/4 is shaded in. Well, now what I'm doing is I'm changing it and I'm saying, okay, well, I'm going to take each piece and multiply it by 2. So I'm going to take each piece and turn it into 2 pieces. So here's 2 pieces. And actually here, let's do this in black so you can see the difference. So here's 2 pieces, here's 2 pieces. Turn this one into 2 pieces and this one into 2 pieces. So now each of those pieces that used to be 1 piece turned into 2 pieces. So now I still have the same amount shaded. I didn't change my shaded area, but now I have 2 pieces shaded in out of 8 pieces total. So 1/4 is equal to 2/8. It's still the same amount of area, but now instead of 1 piece, we split it into 2, and instead of just having 4 pieces, we have 8 because we split all of the single pieces into 2. Okay, so here, how did we go from 1 to 5? We multiplied by 5. And what we do to the, oops, this is incorrect down here. This should be 25. And what we do to the top, we have to do to the bottom. So I know that I multiplied by 5 over 5 to give me 5/25. So how does this work when we have a missing number? So I'm trying to figure out 4/5 is equal to how many 20ths? Well, how did I go from 5 to 20? I multiplied by 4. So what I do to the bottom, I have to do to the top. So I know I have to multiply by 4, and I know that that'll give me 16. So I know x has to equal 16. So I know 4/5 is equal to 16/20. Okay, so again, what you're doing is you're taking this number, and when you multiply it, so you're taking 4 and multiplying by 4. So you're taking those 4 pieces and breaking them into 4 smaller pieces. And then you're figuring out, well, if I did that to my 4 pieces that I shaded in, I have to do that to all 5 pieces in my circle. So I took 5 and I broke each of those 5 into 4 pieces, and that gave me 20. So then those 4 pieces that were shaded in turned into 16. Okay, and again, even if the denominator is missing and I know the numerator, I still know I multiplied by 5. So I know I have to do that on the bottom, and I get 15. So I know that 1/3 is equal to 5/15. Okay, so now we're looking at simplification. Simplification is another way of making equivalent fractions, because when we make equivalent fractions, we can do one of 2 things. We can multiply or we can divide. If you add or subtract, you're not making equivalent fractions because that doesn't do the same thing to the top as you do to the bottom. So if you just add 5 to the bottom and add 5 to the top, you're not splitting the pieces up like we did here. So here we took each piece and split it into 2 more pieces. If we were to just add 5, we wouldn't be doing this equally. We'd be turning 4 pieces into 5 pieces and turning 1 piece into 6 pieces. It just doesn't work that way. You have to think of taking it, and if you take a candy bar, and if you take a candy bar and you split it into 4 pieces, you know that if you have one of those 4 pieces, that's 1/4. Well, then if you take that and split it in half again, you don't have 1/2 because you don't have half the candy bar. You have 1 out of 8. Okay, because you took that and you made the pieces even smaller. So you have to think, okay, well, if I took this one small piece and turned it into 2 even smaller pieces, then all the rest of my pieces had to become smaller as well. All right, so looking at simplification, I have 6/10. How do I know if I can simplify or not? Well, I have to decide, can I divide both the top and the bottom by the same number? So can I divide the numerator and denominator by the same number? Okay, and in order to simplify, and is that number something other than 1? Okay, because if it's 1, well, that's not going to change the answer. So if you can only divide them both by 1, then you can't simplify. Then it's already in simplest form. Okay, so here I have 6 and 10. Both 6 and 10 are even, so I know that it can simplify or can reduce because both can be divided by 2. With 7 and 10, it will not reduce because 7 is prime. So the only number that can go into 7, only numbers that can go into 7 are 1 and 7. And 7 can't divide 10, only 1 can. So since 1 is the only factor that 7 and 10 have in common, that means that I can't simplify it any further. 9/12. Well, both 9 and 12 can be divided by 3, so it can be simplified. And then 5/16. So 5 is a prime number, so it's only divisible by 1 and 5. Well, 16 isn't divisible by 5, so 1 is the only factor that they have in common, so it's already in simplest form. So basically what you're doing is you're looking at it and saying, okay, what is my greatest common factor? If my greatest common factor is 1, well, then it can't be simplified. But if it has a greatest common factor of something other than 1, then it can be simplified. Okay, and let's look at how this works. So even if we don't use the greatest common factor, let's look at 8/24. Let's divide it by, well, since they're both even, they both can be divided by 2. And when I do this, I get 8 divided by 2 is 4, because what I do to the top, I have to do to the bottom. And 24 divided by 2 is 12. Well, they're both even, so I can actually divide that again by 2 and by 2. And I get 2 and I get 6. Well, they're both even again, so I can simplify that even further by dividing by 2 over 2, and I get 1/3. So I had to divide 1, 2, 3 times to get to my simplest form. Well, let's make this a little bit easier. Let's use the greatest common factor. So with the greatest common factor, the first thing that you do, and I'll type this so it goes a little bit quicker, is list the factors of the smaller number. So in this case, my factors are 1, 2, 4, and 8, because I listed of my smaller number. Okay. After I list the factors of my smaller number, well, actually, you can use any method to find the GCF. Okay, so list the factors or use the ladder method. So let's actually do it this way. List the factors of both numbers or use the ladder method to find the GCF of both numbers. Okay. All right, so I'm going to use the ladder method. So I have 8 and 24. Both 8 and 24 can be divided by, well, let's go with 4, because I'm not sure, so we'll go with 4. Well, 8 divided by 4 is 2, 24 divided by 4 is 6, and I know that both of these are divisible by 2, so I get 1 and 3, and I know that's all the further I can go. So I multiply these, because it's only the greatest common factor, so I only do the sides, and I get 8. So the GCF of my two numbers, of my numerator and denominator, is 8. Okay, so after I've found the denominator of, after I've found my greatest common factor of my numerator and denominator, I divide the numerator and denominator by the GCF. And I get 1 over 3. So my answer in simplest form is 1 over 3. So now I know I have 4 steps listed here because what you're going to see next is if we were to do this using a list. So my honest opinion is to tell you guys to use the ladder method to get the correct GCF and then use that to simplify your answer. Because now you've gone from having to divide 3 and 4 times to only having to divide once. Right? If we look at the smaller number and then list its factors, okay, so in this case it's 20. My factors are 1, 2, 4, 5, 10, and 20. And then I look at my next step is to look at the largest number in the list and determine, can my denominator be divided by that? So can 28 be divided by 20? No, so that won't work. Can 28 be divided by 10? No, so that won't work. Can 28 be divided by 5? No, so that won't work. Can it be divided by 4? Yes. So the GCF of 20 and 28 is 4. So I'm going to do the same thing. I'm going to divide by that number. Okay, and then I get an answer of 5/7. If this is still divisible by another number, then you didn't find the GCF. Okay, so like I said, you have options. Basically what you're doing is find the GCF of the numerator and the denominator and then divide by it. Plain and simple. Okay, now by finding the GCF and simplifying, you're making equivalent fractions. So let's use the GCF to make equivalent fractions and simplify. So the GCF of 15 and 20, so I'm going to use the ladder method. Both are divisible by 5. I get 3 and 4. So in this case, the GCF is 5. I divide by 5 over 5, and I get 3/4. So my equivalent, so I know that 15/20 is equivalent to 3/4. Here I have 4 and 9, so if I list the factors of 4, and then I look, does 4 go into 9? No. Can 2 go into 9 evenly? Nope. So the GCF is 1, so this one is already in simplest form. 18 and 27. I'm not sure, so I'm going to use the ladder method. Well, I know that both are divisible by 3. 18 divided by 3 is 6. 27 divided by 3 is 9. So I'm going to go again. Both are divisible by 3. I get 2 and 3, and that's divisible by 1. So I do 3 times 3 times 1, and I get 9. So the GCF of 18 and 27 is 9. So I divide by 9 over 9, and I get 2/3 as my simplest form. Okay, and then 18/27 and 2/3 are equivalent. Here I'm just going to list the factors so we can practice both ways. So I list the factors of 9, which are 1, 3, and 9. I know 21 is not divisible by 9, but it is divisible by 3, so that's my GCF. I divide by 3 on top and on bottom, and I get 3/7. Notice each of my answers, the only factor that they have in common is 1, so I know that I have put my answer in simplest form. And by doing so, I have created an equivalent fraction. Okay, so then using the LCM to make common denominators, when we do this without using the LCM, so if I look at 8 and 10, a lot of times we like to just do 8 times 10 and know that they both have 80 in common. So then I have to take 7/8 and I have to multiply it by something to get to 80. And then I have to take 7/10 and multiply it by something to get to 80. I know that something is 8, so I end up with 56/80. And down here I multiply by 10, and up here I end up with 70/80. I have now made like fractions, so now these two numbers are like fractions, but they're huge. Okay, I don't want to deal with 56/80 if I don't have to. So instead of just multiplying the denominators together, we use the least common denominator, or what we call the LCD. To use the least common denominator, the first thing that we do is use the ladder method or the listing method to find the LCM. Okay, so I'm going to use the ladder method. So I have 8 and 10, and I should put LCM of the, if I write that, we're going to run out of space on the page. So you need to find the LCM of the denominators. Okay, so here both of these are divisible by 2. I get 4 and 5. Both are divisible by 1. Now it's the LCM, so I have to make my L. And I do 2 times 4 times 5. Okay. I'm going to do 2 times 4, which is 8, times 5, which I know is 40. So the LCM in this case is 40. So now after I've found the LCM, I set up my fractions to make equivalent fractions with the LCM as the new denominator. Okay, so step 2. So this is step 1. Step 2, I have 7/8 times something, and I want to get to 40 as my new denominator. 7/10 times something with 40 as the new denominator. My third step, find what you multiply by to get to 40 and multiply your numerator by that number. Do this for both fractions. Okay, so in this case, I multiplied, so step 3. And step 3, we'll say, is what I do in pink. So I multiplied by 5, so I have to multiply by 5, and I get 35. And I multiplied by 4, so I multiply by 4, and I get 28. Okay? So now I have like fractions. So I have 35/40 and 28/40. I've now made them into like fractions, which we are going to find is very important when we have to add and subtract. And I did so by using the LCM, so I was able to keep my fractions smaller so they're easier to work with. Okay, what I really want to make sure you understand here for step number 3 is that you have to do this for both fractions. You can't use the same number for both. So here I used 5 and here I used 4. You have to do it separately for each number. So, and I shouldn't even put 40. So find out what you multiply to get to the new denominator. All right, so why don't we try again? So let's use the LCM to make like fractions. So 3 and 6, I know that it's 3, 6. Well, there's what they have in common. So here, I don't change 5/6. That just stays the same. But 2/3, I have to multiply by something to get to 6. I know that something is 2 and 2, so I get 4/6. So I know that 2/3 is equal to 4/6. So now I have like fractions. 9 and 4. So 9 and 4, I can come down to the side and do 9 and 4. And the only thing they can both be divided by is 1. So I do 9 times 4 to get my least common denominator, which is 36. So in this case, the least common denominator was the two numbers multiplied together. So that does happen sometimes. So in this case, we have to get them both to 36, so 8/9. Notice every time, even though I might think it's simple math, every time I set this up to find my answer, because a lot of times students forget to multiply the numerator by your number as well. Okay, so we have 8 times 4 is 32. So now 8/9 is equivalent to 32/36, and 3/4. We multiply by something to get 36, and I know that something is 9. What I do to the bottom, I have to do to the top, so I get 27. So now I have like fractions of 32/36 and 27/36. All right, 2/6 and 2/4, put them in the ladder. Both are divisible by 2. I get 3 and 2. Those are only divisible by 1. So then I multiply my L. 2 times 3 times 2, 6 times 2, so it's 12. So here, a lot of people like to go to 24 because 6 times 4 is 24, but my LCM is actually 12. So 2/6 times something equals something over 12. I multiply by 2 on both the top and the bottom, and I get 4/12. So one of my like fractions is 4/12. And then I have 3/4 times something equals something over 12. I know I multiply by 3, so I get 9 on top, and so I get 9/12. And now they both have the same denominators, so they're like fractions. Again, when we compare and when we add and subtract fractions, having like fractions is extremely important, and with adding and subtracting fractions, it's required. You cannot add and subtract fractions without them being like fractions. So we need to know how to make equivalent fractions. All right, so for you, what I'd like you to do is I'd like you to find the GCF and then use that to give me your simplified answer for these 4 problems. And then you also have 4 more problems where you're using the LCM to find the LCD and then making your like fractions. All right, as always, if you have any questions, please make sure to write them down or email me so we can go over them in class.